Okay. What happened was, like, when I did it in school, for some reason, it didn't record. So I'm going to quickly talk about questions 2 and 3 and 4 and so on, the questions that we didn't get to record and to publish online. So at this moment, that's what we're going to do. I'm sorry. The answers are already here. I'm going to quickly go over the answers so that you have a pretty good idea of an explanation. For example, you have a table here. There are 29 locations, Starbucks, the coffee shop, and if you add all of this, it's going to be 29 locations. And each location, they collected information from each location. So the first question is, what is the variable? In other words, what were they collecting? What kind of information they were collecting? And they were collecting the number of cappuccinos sold on March 22nd in each of the 29 locations. For example, in this particular entry here, you got 2 stores, 2 Starbucks locations, where they sold 5 to 9 cappuccinos. There are 5 locations where they sell 10 to 14 cappuccinos on March 2nd. So this is the way that it is explained. So the variable is the number of cappuccinos that were sold on March 22nd. So it's very specific as to what they need. The second question is the individual. In other words, who was providing the information? They went to collect the number of cappuccinos. So where did they go? Who provided this information? And the answer is one of the 29. In other words, each one of the 29 locations were providing the information. Each store, they went to a store and they asked, how many cappuccinos did you sell today, March 22nd? They went to another location. Each location is an individual. Now, what is the sample? The sample are all the 29 locations. All of them together, they make the sample of 29. The sample size is 29. Now, the variable is discrete. Discrete means that it has a definitely number. In other words, it's not an infinite number, but it's a specific number. Objects that you count, they are discrete because they are objects. They're not half of objects. They're not an infinite number of objects. So they are objects. So that's what we have that. So that's why it's called discrete. Another clue, but it's not always a good clue, is the fact that there are no decimals. You saw 5 to 9, 10 to 14. There are cases where you have decimals, and it's still discrete. So we'll talk about that later. Okay. F. The next question, which is, what is the? I think we spread look at one, right? We saw the sample size. We did that. The sample size. I think we did the variable. We did the individual. We did the sample. The sample size. This is important. I don't think we got to this question in class, which is class width. The class width is the size of each of these groups, right? So how many numbers are possibly there? And that's a question that we answered before. So the best way to do it, is to look at a class and look at the next class. So there are 5 units. Here, between 5 and 10, there are 5. Between 10 and 15, there are 5. Between 15 and 20, there are 5. And between 20 and 25, there are 5. So the answer to the question is, what is the width of each class? This is called a class. This is a class. This is a class. So this is not a group, it's a class. It's 5. I think in the back of the answer, so the bottom of the answer is 15, so that's a mistake, it's 5, that's class size. It's easy to determine the class size by looking at the numbers that each class begins with. Okay, so we did that one. Now, is the variable discrete? We answered that question. How many Starbucks locations sold at least 10 cappuccinos? So, from this point on, that's where you sold more than 10 cappuccinos. So you need to count how many of these locations, and I think I did it here. You add the numbers of people who have, of locations, that have sold more than 10. And the answer is 5 plus 8 plus 10 plus 4. So here we have 27, right? 27 locations, so more than 10. Now, what percentage is the last question? What percentage is that? So it's the number of 27 divided by 29, which is total. And because it's a percentage, we change it to decimal form by dividing the numbers, and then we multiply by 100 to get to 93. I think the book on the back of the exam or the bottom of the exam, you have a number very close to that. So we're not going to be very picky about that. That's an acceptable number there. All right, let's move on to the next question. Sorry. Okay, the next question is something that we also did, so it's already there. Let's see how we go and explain each one of these questions. Okay, question number 1 is, what is the individual? This is a table that explains the shoe styles. So an individual is the one providing the information. And the one providing the information in this case is shoes. Different shoe styles that are sold in an online outlet. So the individual in this case is who is given the information. In this case is a shoe style. Okay. The next question is, what is the population? The population is all the shoe styles. And what is the population size? Everybody. So we add all of the frequency gives you the different shoe styles that you have, 443. So if you look at the variable, which is what is each individual shoe style providing? They are providing the price. The price. So that's what we are collecting. So this table is about the price. If you look at the top here, where it says variable, there's the price. For example, there are 256 shoe styles that are between $10 to $59.99. In the other case, at the bottom, you have only one shoe style that is between $360 and to $409.99. So obviously you only have one shoe style that goes that high in price. Notice that the majority of the shoe style prices are at the lower end, and as they move in prices, there are less shoe styles. So if you grab this, so like I made like a quick draft, the higher the price, the less shoe styles that you have. So that's what we said, that this is skew to the right. That's the shape of the distribution. All right, now here's what we're going to have a little bit of a question maybe. Is this variable discrete or continuous? If you look at the variable here, the variable goes from 10 to 59.99. The other one was 60 to 109.99. So the prices here are even though they have decimals, it is a definite price. In other words, you can't have another decimal here. It's not possible to have another decimal because this is money, and money only has 2 decimals. You can't have 3 decimals when you talk about money. So the price, even though it has decimal, is an exact price. It's not an infinite. In other words, it can never be 991, for example, or 2 or 3, right? It doesn't continue. It stops at one point, and this is the price of the shoe, 109.99. So because it doesn't have an infinite number of possibilities, it's just one price, we call this discrete variable. Okay. Um, Continuous, this is a good example. Continuous could be like weight. How much do you weigh, right? Because it can go forever. Or also what is the time that a runner finishes a race? You know, it could be any. It doesn't have to be an exact time. It has an infinite number of possibilities within a range. So in that case, it will be continuous. Hopefully that's a little bit clearer. Okay, next question. We did this question also in class, but I don't think it got recorded. That's why we are here, trying to see if we can record the question. The following frequency table shows the test score distribution for a random sample of 25 students taking an introductory statistics classes in college. Find the mean and relative frequency. Relative frequency is when you take each value here is a percentage of the total. So if you look at this, total has to be 1. That's the percentage. So this is 8% of the total, which is 25. This is 25. This is 4% of 25. This is 12%. And how do we find this 12%? Well, if you add all the numbers here and you subtract from 1, you realize that you're missing 0.12. So that's that. So that's 12%. This is 24%. Sorry. This is 20%. And this is 32%. So if you add all of this, it should give you 100. If you look in percentage, it's 100. If you look in probability, it's 1. It's basically the same thing. All of this is out of 25. So the question B, how many students in the sample has scores of at least 63? 63 is this group here, right? At least 63. So we have 0.24, 0.20, 0.32, which we added here at the bottom. We add all of these probabilities, and we came out with 0.76. But this is a percentage. We added percentage, basically. So 0.76 of 25. Remember, everything is 25. So the answer was 19 students. Now, the next question is basically the same as the one before, except that this time they went from 52 to 84. So 52 to 84. 52 to 84 will be this group, right? So we need to add 12, 24, and 20. 12, 24, and 20. You can see this on the bottom. And we get 0.56. Now, this 0.56 is not from 25 because the question says out of 100. Based on this sample, then we can project for the whole population. And we need to get the 56% of 800, not of 25, because question C specifically asks you for 800. And the answer is 448. Okay, let me continue. Next question, and then we'll stop. I think we did this one too, right? Okay. This question is question number 5. Let's take a quick look at this because some of you might not have seen it in class. And this is a chance to talk about this. This is frequency distribution at the edges of randomly selected 27 students in statistics courses in a college is given below. So this tells you that there are 4 students taking the statistics class and they are 18 years old. There are 5 students who are 19, and you get the idea, right? So the first question is make a relative frequency histogram. Relative frequency histogram is very similar to the question number 4, where each of these numbers is a percentage. Here, they didn't give it to me as a percentage, they give it to me as number of students. So in order for me to change this to a decimal or percentage, I need to know how many together you have, and together we have 27. So if we have 27, so we have to divide each one by 27. We divide by 27 each of these frequency, and we change that to a decimal form. If you want to change to a percentage, you multiply by 100. So if you have a calculator, you can quickly divide these numbers into these decimal. We only use 2 decimals. Okay, and then we go here and we make a picture. Look at the bottom, you have the ages of the students, and this broken line here, the yellow part here that is being broken, that's what it's called. It means that we're jumping from 0 to 18. We don't want to start writing 1, 2, 3, 4, 5, 6, all the way to 18. So this shows that I'm going to kind of jump to 18 because that's the first, right? One of the first age is 18, and it goes from 18 to 26, 18 to 26. But the probability, I'm sorry, the percentage of probabilities, I multiply it by 100 so that I get a nice number. So this one is not going to be 15, 0.15, but if you multiply it by 100, you're going to get 15%. If you multiply this by 100, you're going to get 19%. So you get the idea, right? So we use the numbers. If you look here, the highest percentage is going to be 26. This is the highest number. So I'm using this. I got it up to 30, and because 26 between 25 and 30, and I move this y-axis every 5 units. So I create my histogram. Remember, histograms don't have any spaces in between. So I have it like this, and that's the answer for A. B. What is the shape of the distribution? If you look, they are continuously going down and down on the right side. So we call this skew to the right. Okay, so answer the compute the sample mean. To compute the sample mean, you can use the calculator, or you can add all the numbers, right? They are 8, how many 18s you have? You got 4 18, 5 19, 7 20s. So if you want to go the long way, you have to do 1, 2, 3, 4 18s, 1, 2, 3, 4, 5 19s, and so on, and you add all of them together, and then you must divide by 27, because there are 27, I believe, right? We have 27. Yeah. So we have 27 numbers, so we divide by 27. Right? That's very long to do. The easy way to do this problem will be to use some sort of a multiplication table. So you have 418, so you multiply by 4, and you get 72. You got 519, so you multiply 19 by 5, and so on. And then you get the addition of everything, which is 555 divided by 27. And that's the mean. The mean is 20.6. Okay, I think that answers question C. D. Use information from C to fill in the blanks in the following statement. In the sample of 27 students taking statistics, the average age of a student is about, well, the average age is 20.6. So I will accept 20.6 or 21. It's okay, but I'd rather have 20.6 because that is the actual number that we got. Now, based on this information, can we say that the sample data we can have an opinion? Can we deduct? Can we infer that the average age of the student taking statistics courses in college is not greater than 21? Yeah, it's not greater than 21. We did the table, we collected the information, so I believe that yes, we can use that statement because the data, the numbers, came from a sample, a good sample, right? We collected the information from different students from 18 to 26. The problem said that this is a random group, so all the variables are met to call this a decent sample, and because this is a decent sample, it can represent the population, so that is the best choice. In the next question, right, which is question number 7, he talks about a study. Let's read it. A study of 10 countries show that smaller percentage changes in wages, smaller percentage changes in consumer prices. Okay, what that is saying is that if you have prices and wages, the income of people. This is the X, which is wages, right? Wages. As wages go higher and higher and higher, the more you go to the right, it's higher the prices, right? So you can have a relationship, a possible relationship, right? It's not always, but you can have a possible relationship where prices go up and also the wages go up. So as the wages go up, right? The wages go up this way. As they go up, what happens when they go up? The prices, these are the in consumer changes in prices. As prices go up this way, right? Probably wages go up and the prices also go up. That's very true in economies, modern economies. So identify the explanatory variable. Explanatory variable is the independent variable, which is the X, right? It explains why things is happening, and that's the X value. That's why I put that in the X axis. The response variable, that is the dependent variable. This is the dependent variable, and that's the Y, and that's the result of the X. So if we have an X, then we're going to have a response or an answer in the variables. So this is the changes in prices. This is the X, and this is the Y variable. Okay. Now, with this relationship, even if you don't know, there is a number in math that is called the correlation or coefficient, which goes from -1 to 1. The closer you are to -1 is the strong relationship between those two variables. In other words, if you don't sleep well, then what can you have as a result? If you don't sleep well, that will be your explanatory variable, and your response will be you'll be sleepy the next day. So that those two variables are very strong, right? You can have a very strong relationship on the negative side, or a very strong relationship on the opposite side, which is positive. And anywhere in between, the closer you get to zero, the less of a relationship you have. The closer you get to -1 or positive 1, the stronger the relationship. Now, we won't be able to, I don't think that this type of relationships are going to be negative, right? Because the more you earn money, so if you earn $10,000 or $20,000, $30,000, $40,000, as the prices go, as the wages go up, more money, right? You're going up here. I believe that the prices are going to go down, right? So this will be a negative slope, so there will be a negative correlation coefficient. So all these negative numbers are not going to explain reasonably the changes of wages and the changes of prices. It won't be a negative relationship. It doesn't make sense. While the positive one makes more sense, the more you earn, the more things are going to increase in value when you buy them. Now, so this seems more natural. 0.7. 0.7 is very close to positive 1. That means that the relationship between earning money and prices, it starts to be very close to positive 1. Probably will be some dots like that of data, right? And it begins to look like a line that goes up, and that will be described by this area, by this number, because it's close to the relationship of 1. This would not be possible because you will never get a number higher than 1. 1 is the highest value that you can possibly get on this type of coefficient number, so that would not be acceptable. All right, let's see what we have next. Okay, this is a question that we are going to do in the next video. I'm going to stop here for a moment, and then we are going to go back to that, right, in the next video.